Hi everyone. Okay, so with today's video, I'm going to walk us through activity 8.3. This is the one where we're looking at exercise and sleep deprivation. So we have three groups, groups 1, 2, and 3. Group 1 exercised in the morning, group 2 exercised in the evening, and group 3 didn't exercise at all. Okay? And our dependent variable then is how long they slept. Okay? So the first thing I'm going to do here is go to my exercise group, and I'm going to change 1 to morning exercise or AM. I'm going to change 2 PM exercise, and 3 to none, just so that I have labels on everything. I don't have to keep in mind that it's 1, 2, and 3. Okay. All right, so we're going to run an ANOVA, an analysis of variance, by clicking on ANOVA, and then just pick the first ANOVA there. It's a one-way ANOVA. And then my dependent variable is the amount of sleep people got. And then exercise group is my fixed factor. Okay. So let's start by looking here at our additional options so we can get descriptive statistics. Right. So we can look at descriptive statistics for our three groups here. Right. And we can see here that the morning group slept for an average of 7.92 hours. The afternoon exercise group slept an average of 7.38 hours, and the no exercise group slept an average of 6.88 hours. Right. We can also look at a plot here. I'm going to click on descriptive plots and look at exercise group. And I'm also going to look at error bars here. I'm going to look at confidence intervals around them. Okay. So each data point is the average for the group. So we're looking at the average sleep deprivation in our three groups there. So it looks like the morning exercise group slept more than the afternoon exercise group, who also slept more than the no exercise group. But we don't know if those differences we're observing there are because of sampling error or if they're differences that are unlikely to be due to sampling error. So we're going to do an ANOVA, an analysis of variance, and our ANOVA here comes out at the very top of your output. Right? And our overall ANOVA is asking the question, and that is testing the null hypothesis that all three means are equal to each other. Right? So our F statistic here is 11.919 with a P that's less than 0.001, right? That is in scientific notation there. So it's a very small p-value. That means that the difference we're observing between our means is really unlikely to be due to sampling error. The trick is now, all we know from this overall ANOVA is that overall, there is an effect of exercise group on the amount of sleep, but we don't know which groups are different from each other. It could be that group 1 is different than group 2, 1 is different than 3. It could be that all of them are different or only one pair of means is different. Okay? So we need to do post hoc test. Okay? But before we go to post hoc test, I'm going to add in also an effect size here. Under the additional options, we can get an estimate effect size. We're using omega squared. It defaults to eta squared, but omega squared is considered to be a less biased estimate of our effect size. Right? Everybody reports it with their ANOVAs. In this particular case, it's not terribly helpful. It's just telling us that this is the effect size for overall the effect of exercise on sleep duration, but it doesn't break it down per group. Okay. So to break it down per pairwise comparison, we're going to do post hoc tests. So if you click on post hoc tests, we're moving exercise group over into the right-hand box. And we also want to get effect sizes, and I'm going to ask for confidence interval as well. But I'm going to have effect sizes effect sizes for each pairwise comparison. Right? I'm also noticing here under correction, it says Tukey. And now we're going to do Fisher LSD comparisons because we only have three groups, and so we don't need to do this correction. So we're going to unclick Tukey. Okay. So over here on the right-hand side under post hoc test, you can see we're comparing the AM to PM group. The difference is 0.54 hours, or about a half hour of sleep between them. Okay. So the AM group slept more than the PM group by about 0.54 hours. the effect size is 0.495. Right? For the comparing morning to no exercises, the difference was 1.04 hours with an effect size of 0.93, which is a very large effect. And then we have the nighttime PM exercisers compared to the no exercisers. They get a difference of 0.499 hours with an effect size of 0.4, right? A modest effect there. Now you note that we have t-values for these comparisons, but no p-values. So in order to get the p-values, you're going to have to use an online calculator. Right? So an online calculator you can use, I'm using one from graphpad.com, where all you do is you enter your t statistic. Our first one's 2.54. And then you enter the degrees of freedom. These are the residual degrees of freedom from the ANOVA. So it was 162 to compute the p-value. Our two-tailed p-value there is 0.01. Okay, so write that down. Your t-value is 0.01 for that first comparison. Our next t was 4.88. We're keeping the degrees of freedom the same. And here our p is less than 0.001 or 0.0001. Again, write that down. You'll need it later. And then finally, our last t was 2.33. Our degrees of freedom stays the same, and our p is 0.02. Okay, so your p-values for the comparisons were 0.01, less than 0.001, and 0.02. Okay. All right, so I'm going to go back to the activity here. I'm looking in JASP. So now we know that this first comparison, the t with 2.54 had a p of 0.01. Which means that the difference between the AM and PM exercises is unlikely to be due to sampling error. Our next p was less than 0.0001, and so the difference between AM and no exercises is unlikely to be due to sampling error. And then also finally, our last t had a p of 0.02, which means that one is also really unlikely to be due to sampling error. So all of the differences we're observing there are unlikely to be due to sampling error. And so since they're unlikely to be due to sampling error, we infer that it's the treatment causing that difference. Okay. So now, in order to do your write-up, right, you're going to need the data from your, I need the output data that you're going to use to do a write-up. Okay. So the first thing we're going to look at here is I'm going to highlight our APA style summary statement, getting all of the numbers here. Right? So my F has 2 and 162 degrees of freedom. That 2 comes from the degrees of freedom for the exercise group. The 162 is the residual degrees of freedom. So it's always the between treatment degrees of freedom and then error or residual degrees of freedom. And then you give the F you computed. In this case, it was 11.92. Okay? And our P was less than 0.0001. I wrote it out all the way out to I don't know, the 6th decimal there. MSE is the mean square error, which is mean square residual. It's the 1.26 here. And then omega squared is the last value here in the table. Our effect size. Okay. All right. So you get those numbers written indicating that there is some effect of exercise on sleep duration. But then we need to talk about what those differences are based on those Fisher post hoc tests. Right? So for that Fisher post hoc test, we found that people who exercise in the morning slept 0.54 hours more than people who exercised in the afternoon, and 1.04 hours more than those who did not exercise. Okay. The people who exercised in the afternoon slept 0.5 hours more than people who did not exercise it. In this case, all of these differences were unlikely to be due to sampling error. You'll notice here I didn't explicitly talk about effect sizes. I could have talked about small, medium, and large using Cohen's d, but I found that the actual time differences were really meaningful here, right? A half hour of sleep difference or an hour difference in sleep is more meaningful than talking about small, medium, and large effects in this particular case. Okay. So after these results are unlikely to be due to sampling error. We have differences of about half hour to an hour in our different groups. And it seems that exercise was associated with more sleep. And the morning was more beneficial than the evening. Okay. So remember, you also want to consider sort of the scientific literature as well as any methodological concerns. And I know you may not know a lot about the research methodology here, but you could probably infer that maybe we have some concerns about how accurate their measures of sleep were, how accurate people's measures of exercise time were. And those things give you a little pause and make you be a little more cautious, right, in interpreting your results. But overall, these are strong results suggesting that exercise led to greater sleep duration, and also that exercising in the morning was more helpful. Okay. All right. So that is about what you need for Activity 8.3. Don't copy this, right? Work on finding your own way of saying this. There's a lot of different right ways to say this. You don't want to just copy it, but this is a good starting point or example to work with. Okay? All right, I'm signing off then.